Hello, welcome to my channel. Today we have a new chapter that I'm gonna capture all the must-know and high-frequency questions that are from LeetCode and another platform called Linko. So Linko is another platform like LeetCode, but I use it because they have some question that is really famous, but it's not on LeetCode somehow. So we will jump between these two platforms to get every good question out of it. And because I have this series, and it's really important that this question should be memorized, or every line of this code is have to be explained so well by you, because this is a really good before you warm up for the whole practice of lead coding. So let's jump to the code today. So this code is LeetCode 14. In order to use this platform, you can go and sign up with your Google account, and then you can start coding like how LeetCode does. And this is the 14 of this LeetCode platform. So it's saying basically it's a binary search, and the description is giving a sort array with the ascending order and the target number. Find the first index of this number in a time complexity that is required under log n. So if the target does not exist in the array, then we return -1. If you've done any binary search problem before, this is definitely not new to you. So it's really straightforward. Now we have a target, but we're looking at the target in the array for the first existing location. So now 1. So the output will be this location, this index location, which is 0. So for example, if the target is 4, they're looking at the first 4, which is this location, then we output 1. Same happened to 7, this location, 9, this location, looking for the first one. Binary search is usually break them down to half. So we don't spend that much time on explaining what's binary search, but we look at all the detail of how this template works. First, we usually start with getting edge cases num. If num equal to no, so no number there is empty, or num.length equal to 0. At that case, you cannot find any target number there. Then we just return -1 directly. So now we have starting point here and ending point here. So int start 0, int end equal to num dot length -1. So now we have the beginning and end. So we have a while loop saying that start plus 1. So what's that mean? Start plus 1. Some people say start less than n, or start less than or equal than n. But in here, we give you the template saying that start plus 1 less than n. So that means between start point and end point, there must be something in between. If they are next to each other, then this while loop is done. And that's how this while loop works. Next step, we'll have a midpoint equal to start plus start, actually end minus start divided by 2. And this is another concept that we need to care about. Is some people will use start plus and total, the total of start plus end minus 2. This is a really bad practice, because if imagine 100 is the maximum of the type in here. And the start pointer is 98 and 100. So when you add those up, we're definitely more than the 100 right there. So if they add up more than this type can carry, then that's a outer bound for this type can handle. But in this case, you first minus n minus star divided by 2, which is 1. And this is what we want from the gap. We add 98, add 1 from the gap, which is 99 right here. That will never out of bound. All this transaction right here will not be out of bound using this case. It's really safe. So that's the second thing we need to care about in binary search. This is first thing. This is second thing. So next, now we have start and end. So we pick the middle one right here, for example, and we compare if the middle nums mid, right, is equal to the target that we're looking for. What do we do? Because, for example, if this is the array, this is the array right here, and the mid beginning is 1, n is 5, the mid will be 4 right here. But 4 is not the one that we're looking for, even though it's equal to target. But there's still more could be in the beginning. Then if this is equal to target, then we need to move the endpoint to here, that we are still searching from the beginning to the mid, which is this location here. So we change the endpoint equal to midpoint, if that's the case. So another case, else if nums mid bigger than target. If num mid that we are looking for is bigger than target, that means they need to also n equal to mid. You think about it, if the target is on the left side, then you need to move the endpoint to the mid and keep searching the left side. Else, the other way, star equal to mid. If what they're looking for, which is the target, is on the right side, then we move the starting point to the mid by searching the right side. So after that, we will have left and right pointer, which is start and end pointer. Left over, we didn't check it. What we do in here is just try to push them to the one side, to the right side, to the right range. Then, and we individual check the start pointer first. If the start pointer is equal to target, then return start. If end pointer equal to target, return end. Otherwise, we return -1. And that should be it for the template. And this process must be really familiar with all these tricks right here. And why do we need to use this way and stuff? If the question, this question is saying that the first position of the target, if you change the question to last position, if you really fully understand this question, you should be able to know, looking for the top, the last position is something right here. If that's the case, then the star should be mid. If you understand this is the trick that looking for the last position, then you should be able to understand the whole code and write it by yourself at the interview. Let's change this back and it's equal to min. And that's it for this question. And this is the beginning of this chapter, and I will post more. I will jump back and forth from LeetCode and LeetCode, and probably see you in the next question. Good luck coding. Bye.